All right, guys, continuing with our triangle inequalities. This is going to be a short video. We'll have these two theorems. The hinge theorem. Hinge. Think of a door hinge. The wider the door opens, the wider the hinge is, the wider the opening is. All right? That's why it's called the hinge theorem. So what it says is, if I have two sides that are congruent. So see how those sides are congruent to those sides? There's the door, there's the doorway, the doorway, the door. Those sizes are not going to change. So the wider you open the hinge, okay, the wider you open the hinge, if A is bigger than X, the opening must be wider. This is kind of a common sense thing. So the wider I open it, as long as the two sides are congruent, the wider the angle, the bigger the angle, the bigger the side, okay? So if two sides are congruent and one angle is bigger than the other, the third side is bigger than the other side. That's why it's called the side-angle-side inequality theorem. Because you have two sides in an angle. Side, angle, side, inequality. This is a lot similar to your congruent statements. That we'll get into in another video. But you can call it the hinge theorem, or I like to call it the side-angle-side inequality, because I know it tells me I need to have two sides in an angle. I need the information of this to find the third side. So let's look at our two scissors. We're wrapping presents this time of year, so you're using your scissors. You get that glide. It's perfect, right? I never did because I'm awful at things like that, but I digress. We have two scissors, the exact same scissors. If I open one at 35 degrees and I open the other at 40 degrees, right?
Hey Google, turn off the timer.
Which opening will be bigger? This one. Because these two sides are the same. I apologize for that.
Hey Google, turn off the timer.
That timer in the background. Okay. Now, let's look at the converse of the hinge theorem. Remember, it's opposite. You can call it the converse of the hinge theorem. I would use side, side, side inequality. I would use side, side, side inequality because it says I have three sides. So if two sides are congruent and the third side, let's call this 10 and let's call this 8. If the third side of one triangle is bigger than the third side of the other, the opposite angle is bigger than the other angle. It's the side, side, side inequality. So if I know the value of three sides, I know two are congruent and the third side is bigger than the other side, I can then, by the side, side, side inequality, say that this hinge or this angle is bigger than that angle. Let's apply that with a range. Let's look at 5x minus 20 and 60. Which one is bigger? Is 5x minus 20 bigger than 60 or less than 60? Well, let's see. Those are congruent. Oh, do they share SU? Is SU the same as SU, right? That's congruent to itself. Remember, reflexive property of congruence. So therefore, I have two sides of a triangle congruent, and I have this, the third side, bigger than the third side. So that means the angle across from the bigger side is bigger. So this would be less than 60. And this is by the side, side, side inequality. Oh. Is this less than 60, but can it be like negative 50? No. What is the smallest it can be? It has to be bigger than what? It has to be bigger than 0 degrees. It cannot be 0. It can be 0.0034, but it cannot be 0. So we're going to take you back to some algebra and solving a compound inequality. I'm going to add 20 to all three parts. You could separate this into two problems, but that's unnecessary, right? I'm just going to add 20 to all three parts. 20 is less than 5x is less than 80. Then I'm going to divide everything by 5. So x is between 4 and 16. That is the possible range of values for x. It's between 4 and 16. All right, so that was a quick video today, guys. The difference, we have side inequality and side angle inequality. Side angle inequality, I have two congruent sides and the measure of an angle. I'm looking for the third side. Side inequality states I have two congruent sides and I have the third side. I'm looking for the angle. So look at it, what's missing. If it's an angle missing, you hit side. If it's the third side missing, it's side angle side. Or what do I have? Do I have three sides? Side. Do I have a side angle side? Side angle side. All right, you're going to have 2 students complete on what we learned today, then a review from last class, finding a range, and we'll have some classwork, and then a worksheet. All right, guys, see you in class.